Myth 1, this video is for task 5.4, and we're going to be using technology to find the line of best fit, or otherwise known as the regression equation. So we have this table of data here, and it shows some popular sandwiches, how much fat grams they have, and then the total calories. For example, a hamburger has 9 grams of fat, and the calories is 260. But if I look here at the Arch Special with bacon, that one, because the bacon, has 34 grams of fat and a lot more calories. Okay, so do you think there is an association between the two variables? Is there an association? Okay, and I'm going to say yes. Yes. What type of association? Well, the more and more fat it has, the more calories it has. So this is a positive association, okay, or a positive correlation. As the fat grams increase, okay, so does the total calories. The total calories also increase. Okay, now let's see if maybe we can make some predictions. How many calories do you predict that a sandwich with 11 grams of fat would have? So this is just a prediction. I'm not finding any sandwiches that actually have 11 grams of fat. I do see here that it's kind of between 9 and 13. So maybe if I just use these as an example, I can kind of make a prediction. The calories would be somewhere between 260 and 320. I'm going to predict that it has about 300 calories. Now that is a good estimation. It's not exact. I don't know what's on this sandwich, but I'm using this data to kind of predict a number in between. All right, let's keep going. How many grams of fat would you predict? Okay, let's just predict if the sandwich has 800 calories. 800 calories. So let's go see. I don't think any of these have 800. The most amount of calories I see here are 590. And 800 is way more than that. So we got to be way more than 500. So I'm thinking that the fat is going to be way more than 34. I'm going to estimate, I'm going to predict that it has about 50 grams of fat. Okay. It definitely needs to have more than 34 grams of fat, but again, that's just a prediction. Now, what would help us make these predictions more accurate? Okay, because this is just predicting and guessing, and that's not the best. If you want to be more accurate, you need to have an equation. Okay, you need to have an equation. Sometimes they call that the regression equation. The regression takes the trend of the data, or they call that the line of best fit. The line of best fit equation. And so where are we going to get that equation? We're going to use technology to help us. Okay, so please get your calculators out and play along with me. This next table is the same table that we just had. This is the table, and we're going to enter this data into our calculator. Okay, so the first thing I need everybody to do, okay, is get your calculator out. Okay, and we are going to go to the Stat button. The Statistics button, okay, is right here. Okay, so are you pushing these buttons along with me? We're going to push Stat, and we're going to choose option 1. Okay, we're going to edit data in our calculator. Okay, so let's go ahead and push Enter, because we're already on option 1. So I'm going to push Enter, and we should have 2 lists here. If there's any data in your list 1 and your list 2 from prior users, you go up to the name of the list, okay, and we're going to clear out this data. And we're going to push this clear button right here. We're going to clear and then push enter. Okay, and all the data should get cleared out. We're going to push this clear button right here. We're going to go up here to L1 and we're going to do the same thing. We're going to clear out this data. Clear, enter. All right, you should now have two lists, L1, L2, that are completely empty. Now let me tell you something weird that happens, okay? You don't push delete. If you go up here to L1 and you push delete on accident, you just deleted your list. Okay, now don't worry. If you don't have your lists, okay, or if somebody deleted them on you, okay, here's what you do. You go to Stat, and you're going to pick option 5. You're going to set up editor. Okay, so watch me as I do this. I'm going to do setup editor, and then you have to click enter to execute that command. And it says done. Okay, let's go back into our lists. How do we find our lists? You push the stat button. Right here, we're going to go to stat. Okay, and you're going to pick edit. Edit means go into the list. So I push enter. Oh, and now I have L1 and L2. Okay. All right, now it's time to enter in the data. So into list 1, I am going to enter all the data for the fat. So we're going to push 9, enter. The second entry is 13, enter. And then 21, enter. Okay, just go extra slowly, super carefully, making sure we don't make a typo. If you type any of these numbers wrong, or if you skip one, you're going to get everything incorrect. Okay, and the last entry is 5. Now what I want you to do is double check that we typed these correctly. Let's just go up the list. Do I have a 5, 20, 28, 25, 34? I should have 2 31s. Yep, do you? 30, 21, 13, 9. Okay, I want you to double check that you typed everything correctly. And now we're going to go to list 2 and do the same thing. Now we're going to type in the calories. Let's be careful, these are big numbers. 260, 320, 420, 530, 560, 550, 590, 500, 560, or 40, 300. Let's just go and make sure that we typed them all correctly. One more time. Carefully check for typos. Okay, and then there's something else I want to show you. If you go all the way down to the bottom of your data, okay, you should have the exact same amount in both of your lists. If you accidentally missed one, they won't match. Your calculator will tell you that there's a dimension mismatch. And it's trying to tell you that they don't match, that one column has more data than the other. Okay? This is how you take a table of data and you enter it into your calculator. Okay, so we just went over these commands right here. This is how you type data into your calculator. Okay. And the stat button right there, this is the one that we're going to use for everything. The statistics button. All right, now there's a couple things that we can do. We can see a graph of this data. We're not going to do this a lot. Okay, so if you want to just watch, you can. If you want to play along, you can. You don't have to make graphs with the calculator. Okay, but this is just a nice thing to do. If you'd like to view the graph, we're going to use these graphing buttons up here, and we're going to push Y1. Okay. Now, a couple things have to happen. All of your equations need to be cleared out. So if somebody has something in there from before, Okay, just go to that line, go to that equation, okay, and clear it out. And I'm going to make sure that there's no equations all the way down, okay, all the way down to number 10, that there's no equations in here. Okay, now the second thing we're going to do, okay, is we're going to turn the plots on. My plots are on. Okay, so if we go up here and you don't have them on, you push enter to make them dark. Okay, my plots are now on. All right, and then we're going to zoom this is actually a 0. This is actually 0. So if you hit the zoom button, go to zoom button, and you go down here, zoom fit. Okay, there is the data, just as we expected. Okay, as the fat increases, the data increases. Now you don't have to make graphs in your calculator, but if you like to do that, that's the steps. Okay, so let's make a prediction about the strength and the direction by looking at the graph. So looking at this graph, okay, I notice the data is positive. Okay, so the direction is positive. And what about the strength? I'm going to say this is strong data. This is strong. The strength is strong. Okay, let's make a prediction about the R value. What kind of R value do you think this graph has? It's definitely positive. It's definitely positive. 0. I'm going to say 0.9. It looks pretty strong. Okay, but you don't guess R values. Again, we're just making a prediction. That's not the best way. Okay, so here is the best way. Here's what we're going to do. We're going to find the equation using our calculator. A couple of things need to happen. First of all, let's just quit out of here if you played along. Quit out of there. You have to set up your diagnostics, and you only have to do this once. So if you've done this already, don't worry about doing it again. You push second 0. So second, and then the 0 button. Okay, and we're going to look for the command diagnostics on. So I'm going to go down all the way to the D's, looking for this command. I think I already turned mine on, but I'm just going to check. If you turned it on already, you don't have to do this ever again. Okay, diagnostics on. We're going to hit enter and then hit enter. Okay, my diagnostics have been turned on. If yours aren't turned on, you're not going to get all these R values. Okay, and that's how you do it. So you don't ever have to do this again. Okay, so you only have to do this once. Okay, check. Okay, only have to do this once. Now, if you're not using your own calculator, you're going to have to remember how to do that. Okay, and here we go, to find the regression equation. Okay, if you have a little, if you have like a little paper like this, perhaps, your teacher gave you, you could push stat. Okay, so we're going to push the stat button right here, like we always do, the statistics button. Okay, now the first time we edited the data. Now the second time we're going to go calculate. So you need to arrow over to calculate. And now I want to get the equation. Okay, and here it is, number 4. Okay, so you pick number 4. We're going to go there to linear regression equation. Linear regression equation. Okay, and we're going to pick that one. Hit enter. So it's going to use X for L1, Y for L2. Okay, yes, 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 and we're going to calculate. So hit enter. Okay, here is the regression equation. So it has this in your calculator. y equals ax plus b. The a value, and we're going to round to 2 decimal places, okay? So we're going to say the a value is 11 point. If we cover this up, should I leave it 73 or should I bump it up to 74? We're going to keep it 73 since 1 is a small number, and that is the a value. The a value right there is the slope. The b value is 193 point. Let's go ahead and round this to 2 decimal places. Should it stay 85 or should I bump it up to 86? Since this is a small number, we're going to keep it as 85. The b value goes right there. That's the y-intercept. Okay? And then the one that we need is the r value. The r value is the correlation coefficient, which again, let's round it to 2 places. 9, 7, and under my finger is small, so we're going to say 97. Okay, that is strong. Okay, that is strong. Now, how do you use these numbers to make the equation? Okay, you're going to use this formula right here. Y equals, okay, the A number right there, 11.73x plus the B number. The B number is 193.85. And that is the regression equation. This is the regression equation that the calculator found for you. We would never be able to find it that accurately ourselves. Okay? Now, if you would like to see this equation on the data, you can. This is not something you have to do, okay? But if you go back to the y equals button, I'm going to type in this equation. 11.73x plus 193.85, and then I'm going to push the graph. Push the graph, and look at that, the line of best fit. It's going right through the data. Okay, so how can you tell this line is appropriate? Well, a couple things. It follows the trend. It follows the trend of the data. Okay, it's going up in the right direction. And importantly, half the points are above the line and half the points are below the line. Okay, and so that is how you use this calculator to do lots of technology. Let's go ahead and practice with this and talk about this a little bit. Okay, so our regression equation that the calculator gave us was this, and the R value was 0.97. Let's use this equation to predict. Okay, so now we're going to make better predictions. If the sandwich has 11 grams of fat, how many calories does it have? Now, grams of fat, if we go back and look at our table, grams of fat was the x variable. That was the x variable. Okay? And we have to find number of calories, which is the y variable. Number of calories is the y variable. So I'm going to take 11 and I'm going to plug it into the x spot. Y equals 11.73 times 11 plus 193.85. And what is your calculator giving you when you do this calculation? Did you do it? Okay. I hope that you got an answer of 322.88 calories. Okay, 11 grams of fat would have 322 calories. let's go back a page and see when we made our prediction, what did we say? 11 grams of fat, we guessed 300. It's actually 322.88. How does that compare to your original prediction? Okay, we were pretty close. We were pretty close. Now let's use the equation to predict. Okay, again, we're going to predict using the regression equation. How many grams of fat if the sandwich has 800 calories? Now, calories is the y value. So we're going to plug 800 into the y spot, 800. Okay, and now we're going to have to find the x. Okay, so how are we going to find the x? We're going to have to use our solving skills. First, we're going to subtract 193.85 from both sides. Okay, from both sides, it's going to cancel here. 11.73x. Let's use our calculator. What do you get when you do 800 minus 193.85? I hope you got 606.15. Okay. And now we're going to have to divide both sides by 11.73. 11.73, so divide your answer. And what do you get for x? I hope you got 51 point. Let's round this to two places. Let's round this to two places. So is under my finger big or small? It's big, so we're going to say 68. 68. And what does x represent? X represents the grams of fat. So 51.68 grams of fat. Now let's go back a couple pages. How does that compare to our prediction? Okay, back a couple pages here. 800 calories. We guessed about 50, and it's 51.68. We were pretty close. Okay. Were you surprised by the R value? The R value is 0.97. Okay. And I'm going to say that I was not too surprised by this. I'm going to say no, okay, because the data was definitely positive, okay, and it was strong when I looked at it on the graph. The data looked strong. Okay, we're going to try one more just to make sure that we're good with the calculator. Sometimes they give you data, okay, that is for years. The supermarket monitors how many diapers are sold each year, so they can predict how many diapers are going to be sold the following year. And this table shows the sales from 2016 to 2020. Okay, so sometimes when they're years, it's really big numbers, they change it. Year 0 is going to be 2016. So this is 2016, 2017, 2018, 2019, 2020, and so on. Okay, but when it comes time to type in the calculator, 0, 1, 2, 3, 4 is a lot easier. Okay, let's get our calculators. The first thing we have to do is find the equation of the regression, and we use our calculator for that. Okay, so here's our calculator, and here is our little cheat sheet. Okay, so the first thing we do is we go to Stat. We push the Statistics button, okay, which is right here. We're going to push that, okay, and you choose number 1. I'm just going to write on here, okay, that stands for Edit. We're going to go to Edit. Okay. Now it says clear up old data, and I definitely have old data to clear up. You arrow up, okay, you hit the clear and the enter button. So here's the clear button and then the enter button. Okay, list 2 has been cleared. Let's arrow over to the top of L1, clear, enter. List 2 has been cleared. Okay, step 4 is type the input and output. Okay, so when I'm looking at this data right here, I have this data table. The years, okay, is going to be the X variable, and I'm going to put that into L1. So I have to type a 0, enter. 1, enter. 2, enter. 3, enter. 4, enter. Let's just check. 0, 1, 2, 3, 4. Okay, no typos. Into list 2, the diapers is going to be the Y. So we're going to go over to L2 and type in, okay, this huge amount of diapers. 60,200. Enter. 65,000. Enter. Go slow and make sure you don't make a typo. 65,200. Enter. 70,600. Enter. Okay, let's just double check the data. And let's make sure you have the same amount in both of your columns. Okay, so we entered the data. Okay, now it's time to get the regression equation. So we go back to stat, our statistics button. We always go back there. Okay. The first time we do edit. But the second step is to go to calculate. Go over to calculate. Okay, and it's saying pick option 4. Okay, I'm just going to write a note here. Option 4 says linear regression, and that's the AX plus B equation. So that's the one we want. I'm going to push enter, and I'm going to go calculate, enter. Okay, so there is the equation, but now I have to write this down on my paper. Okay, and it'll tell you how to make, where should I put this? It'll tell you how to write the equation, y equals ax plus b, and the a value came out really nice. 2,100x plus the b number. The b number is 61,260. Okay. The next question here says, what is the correlation coefficient? And that's your R value, and that's on the bottom. Okay. If you don't have this, your diagnostics aren't on. The R value is 0. Let's round it to 2 places. You cover up with your finger. Since 4 is small, we'll stay 89. 89. Okay. Is that correlation coefficient strong, moderate, or weak? 0.89. That is strong. Okay. It's definitely strong. Is it positive, negative, or nothing? Well, that's definitely a strong positive. Okay. The data is going to be going uphill in a direction like that. As the years increase, the diapers increase. Okay. Of course it does. Look, the diapers, more and more diapers every year. Now, let's use the regression equation to make a prediction. Let's predict, okay? How many diapers will they sell in 2021? We have to be super careful here. 2021 is a year. This is an X value. But our X values have to get changed. 2021, okay, would be right here. 2021 would have an X value of 5. So we're going to plug in a 5 into our equation. Okay, so you don't plug in the year, 0, 1, 2, 3, 4. 5 is going to get plugged in to the X spot. Let's calculate. 2,100 times 5 plus 61,260, okay? What do you get for y? What are you getting for y? Y is diapers. How many diapers are they going to sell? Did you calculate it? All right, let's see. 21 times 5 plus that. They're going to sell 71,760 diapers. And now we're going to use that equation again, okay? But we're going to go backwards. Again, we're just going to predict, so we're going to use the equation to predict. When will they sell 90,000 diapers? Okay, diapers is the y. So we have to plug 90,000 into the y spot. 90,000 is going to go right there. 90,000 equals 2,100x plus 61,260. Let's go ahead and use our solving skills for this. Okay, we're going to have to subtract. Let's do this one. We're going to subtract 61,260 from both sides. Okay, those cancel. What do you get when you subtract 90,000 minus 61,260? What did you get? I hope you got 28,740. Okay. And now we're going to divide both sides by 2,100. Okay. X is, we're looking for X. We're looking for X. Let's see what we get here. We're going to divide by, oh, we have a decimal, so we're going to have to round. 13 under my finger here. You cover up, under the finger is big, that's a 5. So we're going to round this up to 69. Okay, but the question says, okay, when will they sell that? When will they sell that? So we have to tell people a year. We have to tell people a year, okay? 0 goes with 2016. 1 goes with that, 2017. So we have to add on to 2016 to this X value. 1, 2, 3, 4, 5, 6, 13 years from now, okay, let's take 2016 and add on 13.69. So it's going to happen in the year, it's going to happen in the year 2029. Okay, in year 2029. Okay, great job, math one.